So last time we defined something that had data elements, had some instance members, instance meaning non-static, meaning that you had to create a chord before you could set the value. There are also static members in static methods where you don't have to implement, where you don't have to instantiate an object before you call it. So I'm going to make a A&T project. If you're doing it at home, choose A&T so you don't have to create the file by hand. I'm going to call it Lecture C. And the first thing I'm going to do is, what is this package statement? This tells it to put it in a subdirectory of the project, right? I don't want it in the subdirectory. Why? Because if you mail it to me and I want to compile it, then that line's going to give me an error. So I'm just going to drag it out. You see, I'm going to click on it and pull it up there. And it's going to ask me if I want to do that. And it removed the package statement. Or I could have just deleted, and I know some of y'all know this, I could have just deleted the package statement itself and saved it, Control S, and then come up here and it would tell me, yo, it's in the correct package. Why? Because it's still in the directory. Changing the statement doesn't change what directory it's in. But clicking up here and saying move class to correct folder does. Now if I look into projects, it's in the right folder. And I could delete this folder right here if I wanted to. Not that it hurts anything, but I could. So if you're going to mail your code to somebody else, or you're going to submit it to me, you could just give them the .java file. But if it's a complex project with multiple files or multiple packages, you might want to export it. The way you export it is to choose File, Export Project to Zip. Now this interface is slightly annoying because it puts it in some temporary directory. You have to choose the correct directory through this not the world's best interface. You know, save it in my desktop or whatever. And then you have to give it a good file name, including .zip. A lot of people would type in a file name and forget the .zip. Now, no reason to really do this. So I'm going to cancel this. But this would create a .zip file that I could then, if you mailed that to me or uploaded it to me, could import. I just as soon just have the .java file. But by the time we get around to creating multiple files, and as a matter of fact we did last time, would have been a good idea to export it so that we could, do all the files in one fell swoop. Either way works. Okay, so Lecture C. Here I'm going to use an object with instance methods, meaning I have to create an instance of it. And that's just a scanner class. Scanner SC equals new scanner parentheses capital S system.in, and I'm going to use the scanner for some input. But it doesn't know what a scanner is because I don't have my import up here. I could ask NetBeans to fix it for me. Add the import for java.util.scanner. Or I could do it myself up here. Right, import java lowercase j dot util lowercase u dot scanner. But I'm not going to type scanner. I'm just going to say java.util.asterisk to bring in everything from that. Doesn't slow anything down to do that. And that way, if I start using other things from the java.util package, I don't have to keep going up and adding additional imports. Wouldn't be a bad idea just to put that by habit at the top of every program I create. There's probably a way to modify NetBeans templates to do that automatically for me. Well, anyways, now I've created a scanner and I can use it. I can type in sc.nextInt. Right. Now that's dumb. They don't know they're supposed to type anything. So, that's a pointless statement. But notice, it's the thing before the method call is a dot. And before that is a variable, not a class, a variable. That makes it an instance member because this is an instance of that class. So I'm calling an instance member there. How about a class method or a class member? If you have a class member, you don't have to create an object. So like math.pow, double x equals 3. x equals math, capital M, dot POW, parentheses, x comma 2. In parentheses, delete all the rest of that and add a semicolon. All right, there, right? I did not have to create a math object in order to get .pow out of it. So this is an instance member, or an instance method. I had to create an instance of the class before I could call it. Here, this is a class method. Now you'd think, well, it's part of a class, everything's part of a class, so everything's a class method. No, we're using a specific nomenclature that the book outlines. And it differentiates between class methods and instance methods and variables. A class variable and an instance variable are the same way. Math.py is an instance variable, right? If I did this, x equals math.pi, that's a class variable. I said it was an instance variable. That was my mistake. Sorry. That's a class variable. Meaning, don't create an instance of the class to use the class method or variable. Just use the name, not an instance. See the difference? So, in effect, if the thing in front of the dot is capitalized, it's a class variable. If the thing in front of the dot is not capitalized, it's an instance variable or instance method. Why is that? Because we're supposed to name all of our classes with uppercase letters, and we're supposed to name all of our variables lowercase. It's just convention. Now NetBeans giving me some warnings that I assigned these values and I never used them. Yeah, you don't have to fix all your warnings, but it's a valid complaint. But I'm not writing, working code. I'm just writing demonstration code, so I don't care. If I didn't print it X out, it would make that error go away. If I reverse the order of these, it would make the other error go away. Whatever. I'm not going to fuss with it. How do you declare a class method or a class variable? You use a static keyword. So if I wanted to make some kind of class that had a static variable in it, it's going to be a silly example, but I'm going to come up here above public class lecture and I'm going to say class demo, whatever. I have no idea what this is going to be, so I'm just calling it class demo. Notice I didn't make it public. That's because if you're putting multiple classes in the same .java file, only one of them can be called public. And that's the one that matches the file name. All right. Now I'm going to make two variables. Public int x, that's an instance member, instance variable, and static, or public static, don't think it matters which order that's done in, public static int y, that's a class variable. The word static makes it a class variable. So why didn't they just use the word static everywhere instead of calling them class? I don't know. Because they adopted it from the C++ language, so it's the C++ designer's fault. Alrighty, so if I'm going to use that class, if I want to access that y variable, I can do so without creating it because it's a class variable. So I put the name of the class in front of the dot. Demo.y equals 3. Right, that worked. But I can't put demo.x equals 3 because it's an instance variable, so I have to have an instance of the class. I have to have an actual variable that I can use, an actual object. I'm going to try it, and then it's not going to work, so I'm going to delete it, so don't bother typing along with me. Demo.x equals 7. Well, right, that's an error. Can't get a hold of it because I don't have an object. So I'm going to create a demo object. Demo d equals new, capital D, emo, D-E-M-O, parentheses in parentheses, all calls to new. The last thing you're going to see are the parentheses. Okay, and then I can set d.x. You see that x up there? I can call it d.x, equals 4. And if I print out d.y, it's going to say that d.y equals 3. Well, how's that possible? D wasn't even created by then. It's because this variable applies to all objects of the same class. More specifically, it applies to the class itself, even if you don't have any objects created, which we didn't at that point. So if I printf that value, system.out, or just print, right? Println d.y equals end quote plus d.y. It's going to print that d.y is 3. And I wonder why he's giving me a warning here. Accessing a static field y. So every object of that type shares that y variable. That being the case, I don't even need an object in order to access it. I didn't do it up here. So it's warning me. It's saying, why did you call it d.y when it's really demo.y? So to make the compiler happy, to make that warning go away, I could replace with a class reference. I don't think I'm gonna. I think I'm gonna leave it alone. Maybe I'll add a comment, right? So my comment's gonna be should be demo.y because it applies to the class as a whole. You use the name of the class to access class variables and class methods. To declare a class variable or a class method, you use a static keyword. If you have a static method, it can only access other static members. I'm going to slow down on the typing because some people are catching up. No problem. But the next thing I'm going to do is I'm going to create a static method of the demo class. So it's going to be a class method. And the only thing it's going to be able to access is other static members. So it's not going to be able to get a hold of X. It'll only be able to change Y. Well, let's do it. Public static test underscore Y. I'm just going to test that variable. I guess that's just going to print it out. Right. Parentheses in parentheses. Semicolon, not semicolon, curly brace, y equals, well, why don't we just print it out? System.out.println parentheses y in parentheses. And I'm getting an error here because I forgot to give the function a return type, the method return type. Every method has to have a return type, even if it's not doing anything. If it's not doing anything, it returns void. So I should have had the word void here. My mistake. I just fixed this line. Don't add those comments. That's just to zero you in on what I had to fix. And it'll compile and run just fine. I'm not going to even call test y. The point of it is to show that a static method can access other static members. But only static members. If I tried to do this, if I tried to do x equals 7, this is an error, so don't even bother unless you're going to put a comment on it. Right? That was an error. Flagged it as red. It would no longer compile. So commenting that, I'm going to say can only access static members of the same class. But that's because this method is static. If it was not static, we could do both things. We could get a hold of y and we could get a hold of x. So if we're inside main and we start adding other members to the Lecture C class, they better also be static or else we won't be able to get a hold of them. Alright, so this is the demo class. I'm not sure what else I'm going to do with it. Pause your recording and make sure you type it in if you have it correctly, if you have syntax errors. And here is our main method so far of the lecture class, right, all the way down to here. And a little bit further, we had a couple more statements. Is anybody getting syntax errors in here you'd like help with? Nope, all good? All right. So when you're calling a method, the thing in front of the dot, if it's an instance member, is called the calling object. Here they created a mouse with that line, and then they called some methods that were attached to the mouse. So that variable is the calling object. And if you created two mice, you could call different, the same methods on two different objects. Now this class that they're showing is based on the idea that each lab mouse has a weight and an age and a growth rate. We could mimic that rather than use their example. I'm going to scroll up here and create a mouse class. And I'm going to create a rat class. Rat, excuse me, I need to prefix it with the word class, rat, capital R, because all class names should have a capital initial letter. And it's going to have a weight, like in grams or something. I should call it grams, or weight in grams. Right? How about I just call it grams? It's easier to type grams. And then an int, an age. And then a double, which is a % growth rate, right? Growth underscore rate. And by the way, the books don't recommend using underscore. The books recommend using capital letters and doing it like that, right? That's what the book wants us to do. But I'm going to go ahead and do it this way because I want to. These should all be marked as public. If you leave the word public off, they default to something very close to public. They're accessible to anything else in the same package. I'm going to leave them off. All right, now I'm going to make a method called grow. And when we call grow, it's going to increment age by 1, and it's going to multiply grams by the % growth rate. Well, this doesn't have an initial value, so it's going to initialize to 0. So every rat we have is born weighing 0 grams. So is it ever going to get any larger? No. We better default it to something. Let's say that every rat that is born defaults to 5 grams. We might want to make it so that that can be overridden when the object is called. But we're going to leave it like that for now. And the age, why don't we go ahead and say equals 0, even though technically every variable in a class is initialized to 0 if you don't give it a value. Same for growth rate. What are we going to do? Let's set it to 1%, right? So equal to 0.01. But let's make a method that calls grow, or that a method called grow, which increases the age and increases the grams by the growth rate. So it doesn't need to return anything. I really should be marking these all as public. Public, just for absolute correctness. Public, 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 and then public void grow. Why am I making it void? Because it doesn't need to return anything. It's going to change several values, but it's not performing any calculations. It's not like a get diameter method or a get age or anything. It doesn't need to accept any arguments, so I'm not going to put any parameter variables between the parentheses. Curly brace, close curly brace. So when something grows, this dot age plus plus, and age increases by 1. For you Python users, that's the same as typing this dot age plus equals 1, which also works. But most languages have a plus plus operator, and it looks a little cleaner, so I'm going to use that. And the grams needs to increase. This dot grams increases by this dot grams times this dot growth rate. I believe that'll work. like if it was 1 to mean 100%, then each time it would double its weight, and I think that'll handle it. Yeah, I believe that'll work. Let's compile it, make sure I don't have any syntax errors. I'm going to go down to main. I'm going to add a comment to the effect that this is the end of the rat class. You can put classes inside of classes, but that gets confusing. So I'm not going to do that. I'm going to keep each class outside the other class. And so in main, I'm going to create two rats. Rat R1 equals new rat, parentheses in parentheses. And then rat R2 equals new rat, parentheses in parentheses. But R2 grows faster. So I'm going to set him a different growth rate. He's going to grow 50% each time. R2 dot growth rate equals 0.5, which is semicolon, which is the same as 50%. Now let's call grow on both of them. R1.grow, parentheses in parentheses, R2.grow, parentheses in parentheses. And the book has a display or a print or show info method on the rat class that'll print information out about it. I think that'd be a good idea. So even though we don't have that method yet, I'm going to call the print function on them. R1.print, parentheses in parentheses, R2.print, parentheses in parentheses. But that doesn't work because we don't have that method inside the rat class, so I better go up and add it. I'm going to show you something and then I'm going to undo it, which is that if I clicked on this error and I say create that method, it would actually add the method, but with an error message in it. But I really don't like to encourage people to click on create too often because they start making mistakes like this. I'm going to type this and then I'm going to delete it immediately, so don't do it. Like what if I forgot to lowercase it? Right? Like I said, don't type this. You see an error. Oh man, create? Cool, that sounds cool. That'll make the error go away. And yeah, it did. How did it make the error go away? It created a brand new class when the mistake was actually that I didn't have it capitalized. Right? So don't just willy-nilly click on these errors and choose create in order to make the errors go away. Quite often it's the wrong thing to do. Now in this case it'd be the right thing to do. But I'm going to go and create it by hand anyways. So up under the grow method, after the close brace, public void print, parentheses in parentheses. Now it'd be cool if this rat had a name variable so that we could print out, you know, that this is Mickey and he's this many days old. But we didn't create a name variable. Let's just print out the information we have. System.out.println, parentheses, quote, rat, space. I'm going to make a printf so that I can fill in the variables. Right. Rat, age equals %d. D stands for integer. Sounds strange. You'd think it stands for double, but it doesn't. And then the grams equals %f because it's floating point. \n because I want it to go to the next line after it's done printing. Then after that quote, I'm going to put a comma and I'm going to list the variables that are going to fill in these two placeholders. So this dot age fills in the age placeholder right there, and this dot grams fills in the grams placeholder. Now I believe I have fixed all the errors. I believe it'll compile now. Nope, I don't know about that. I see that's still up here. Well, let's save it, see if that goes away. Good, it did. All right, I'm going to run it. Hammer and broom it. Green arrow it. And so the rat that increases at 1% per day only increased by 0.05 of a gram. The one that increases 50% a day earned half its weight again, right? So it seems to be working. So the calling object for this grow method is the R1 object, and the calling object for that one is the R2 object. And so each one holds different pieces of data. Now if we mark them as static, they would not hold the different pieces of data. They would all share that data. But I don't want all my rats to share the same age, so I'm not going to make the age variable static, nor the grams variable. Conceivably, we could make the percent growth rate a static variable, but then every rat would have the same growth rate, which might not be legit. So I'm going to leave it as is. Anybody got syntax errors yet? No? Alrighty. Yay, I get to do something. Okay, so about this printf statement, which you may not have used much in Intro to Java, these placeholders get filled in. If you've done Python programming, you're used to the idea of the placeholders. If you haven't taken Python, though, which is quite likely, let's mention what the placeholders are. %f is for float, floating point values. %d is for integer values. And although we didn't mention it, %s is for strings. Inside this float, we can specify how many decimal points we want to display. Because when we ran it, it printed out like 6 decimal points. What if we don't want 6 decimal points? What if we only want 2? Then we change this percent to %.2f. That means a decimal followed by 2 places. And now when it runs, it prints out 5.05 grams and 7.50. So I kind of like that. But if you don't specify a width, right, if you don't specify that .2, then it'll just print out 6 decimal places by default. So let's add that as well. %.2f means 2 places after the decimal. So again, we see that a class is a template, a blueprint for an object, right? We have an object R1 and an object R2. The object is a collection of data and the methods that use that data. And I usually have a series of rules about, what makes a good class. Getters and setters, data public and private. Since I cheated, it did not make setters and getters. I'm just going to let NetBeans do it for me. I've done this before. You've seen me do it. I highlight the variables. I choose Refactor, Encapsulate fields. And that adds, well, what do you know? What if I save it first? Will it then let me do that? I'm not sure I've ever seen that error. I saved it with Control S, and I'm going to try it again. Oh, well, what do you know? Huh. Oh, well. I'm not going to fix it then. I would just have to add, I would just make these private rather than public, and then I would add, get age and set age and get, growth rate. I'm going to leave that alone. Well, what if we wanted to be able to do this? What if we wanted to be able to create a brand new rat, rat R3 equals new rat, and I wanted to say this rat started off, he's a big old chubby guy. He weighs 100 grams, and his growth rate is 0.05, or 0.05, because that makes it easier to read. And that doesn't work, but I can make it work. Who remembers the name of the method that I would have to add in order to get that to work? I'm going to have to go and add a special kind of method. Kind of a synonym for builder. What's a synonym for build? Constructor. So I'm going to go and add a constructor to this class so that I can specify the weight, the grams. And why not specify the age as well? Because I'm just pretending they always start off at the age of 1. Why not? I mean, well, let's specify all three of them, right? So this guy's going to start off 10 days old, right? Age equals 10, right? Grams equals 100. Rate equals 0.05. That's what I want it to do, but it doesn't do it yet because this method does not exist. But he's offering to build it for me. I'm not gonna. See, it says required, no arguments, but what it needs is an int double. So I'm going to go and create a method that has an int, and a double in it. This is going to be a constructor. So I'm going to come up here. I like my constructors to be right under the data, personal preference. Now when you add a constructor, I would consider adding a default constructor, because as soon as you add a custom constructor, Java removes its default constructor that it was previously using. If you don't add a constructor, you get a default constructor. And what does the default constructor do? It just doesn't do anything. Whatever these initial values are, it doesn't change. So I'm going to add a default constructor. A constructor is a method with the same name as the class, no return type, and can accept arguments or can have parameter variables to set the values of the variables. A default constructor doesn't set those. I mean, I guess it could, but it doesn't take any arguments. Let's add a default constructor. Why? Because, well, let's wait on that to watch it break. I'm not going to add the default constructor. I am first going to add. So it does not have a return type. So I'm not going to say public void. It just flat out doesn't have a return type, not even void. But it has the same name as the class. And it's going to accept the age and the grams and the growth rate. So int age, comma, double grams, comma, double growth underscore rate, in parentheses, and we're going to set those three instance variables with these three parameters. So I'm going to type this dot age equals age, this dot grams equals grams, this dot age equals age, this dot grams equals grams, semicolon, I'm forgetting to say semicolon, this dot growth rate equals growth rate. There we go. So why did I use the this keyword? To point out that this particular part applies to that variable and not this parameter variable. Also, it's nice just to be able to type this dot and have it pop up a list of variables. Right. I like that. Okay. So that's great and all that. That fixed it so that this call down here, where I created a rat and I said that he weighed, 10, I mean his age was 10 and he weighed 100. No problem. Whoops, these fail now because they're using a default constructor. The default constructor is the one without any parameters. Doesn't have any parameter variables. I should have said arguments. So easy to confuse the two. The argument is the thing that goes here, and the parameter variable is what you declare up in the method. So we're going to have to write a default method, or we're going to have to change this to pass in the three arguments. I don't want to change all my prior calls. So I'm just going to breathe a heavy sigh and add a constructor for rat that doesn't accept any parameters. So this is a default constructor, no parameter variables. Default rat, parentheses in parentheses, default. It doesn't even need to do anything, so I'm just going to put an open and a close brace, right? Or I could even put them here. Some people do that, right? Won't put them both though. There. So that's a default constructor. It doesn't need to do anything. But it has to be there for the code to compile. If you add a custom constructor, a parameterized constructor, which we did. Now if we scroll back down, we'll see that the errors are gone. Once you get all that typed in, scroll back down and make rat3, R3 grow, and print him out as well. So under the place where you create them, under the new statement, just call r3.grow and r3.print. Back down here, r3.grow, parentheses in parentheses, r3.print, parentheses in parentheses. So obviously he's going to have different data because the calling object is different. So if I come and look, yeah, he was quite older because I started him out at an age of 10. He weighed a lot more. All right. So since I say these over and over and over, I'm going to tack it on as notes. Class is the template or blueprint for objects that are a collection of data and the methods that use that data. That doesn't mean that every class absolutely has to have methods or every class has to have data, but this is the usual. Rules for classes. 1, capitalize the name. Don't always mention that, but I'd like for you to do so. 2, data, should the data be public or private if I'm doing good programming, which I didn't. Private data, and the methods are public. 3, add a custom constructor. The technical name for that is a parameterized constructor. If it makes the class easier to use, and I forgot 3 actually should be add getters and setters. So I'm going to change that to 4. I'm going to insert a line, right? 3, add getters and setters. Now, do you have to make your data private? Do you have to have getters and setters? No, but it's considered good practice. So we'll teach 2 of the good practices. Now we're a little bit ahead of the book because we're talking about constructors and this chapter doesn't talk about constructors, but that's okay. It's important enough for us to mention over and over. And this should be review, but I don't care. It's important enough for you to see and review. There are other rules that I like, which is to add a copy method and a dot equals method for comparing them and a toString method. But I don't think I'm going to spend the next 15 minutes adding those methods as well. So we're going to leave our rules there for now. We good to go, everybody? All right. So the this reference. And it's always annoying when you start talking about the this reference because you realize how many times you use this in these sentences. Like if you start saying this C and this keyword and this, you know, anyways. So when do you use that? You don't have to use it every time. But you do, it's helpful if you use it. You use it inside of instance methods, and these are all instance methods because they're not static, to refer to instance members. And it just makes it easier to type and it makes it easier to zero in on what it means. If my constructor was supposed to call grow, I could do this dot, I don't see any real reason to do this, but I could type in this grow, right? And this keyword indicates that whatever follows is a member of this class. You don't have to go and look for it. You don't have to wonder what it does. Now this is giving me grief about it. Make the class final, make the method grow final. It's offering all sorts of fixes, and the technical reason for this particular error, I've never totally understood it. And any of these mistakes are going to break the code, so I would just leave that. For example, if I make grow private, what's that going to do? It's going to break all the code down in main. I'm not going to do it. And as a matter of fact, I'm going to delete it. But you've seen by now that if you type this dot and you're using a good editor like Eclipse or NetBeans, it'll pop up a list of all the members of the class that are accessible. and you use them to distinguish between other variables that might or might not have the same name. What do I mean by that? Down here in grow, and don't type this, I'm going to wind up deleting it. I could do int age is equal to 8. Like I said, please don't type this. And then when I do this dot age plus plus, it's not going to change that one. It's going to change this one because that's what I want it to do. Now, is it dumb to have temporary variables that have the same name as your methods? Yeah, that's real dumb. I wouldn't do that. However, you saw up here in our constructor, it kind of looks good to have our parameter variables have the same name as the variables they're setting. So it's a good idea. Now, if you don't have any confusion between the variable names, if there's no other age variable that it can be confused with, you do not have to prefix it with this dot, right? It still knew that age was a member of the class, and it colorized it green, as opposed to what it would have done if I'd done int age, right? But if I type int age, now it's referring to that variable. And if I wanted to actually change the member of the class, I would have to prefix that with this. I use it as a matter of course always. The only time you can't use it is if you're referring to a static variable. Why? Because a static variable doesn't have an instance, and so there's no such thing as this object, right? I don't have this demo to change that static variable. I may not have ever created one. So up here in test y, I cannot do this dot y. Just can't use the this keyword for static variables with class variables. What do they say about it? This, when used with a dot and an instance variable, it's referred to as the this reference. Their rat has a % growth rate and a this dot weight, right? This dot %. So we know that these are two members of the mouse class that they created. It's used inside of a method to refer to the object that is called a method. It is the calling object. This dot is the calling object. So what's so great about having a special name for the calling object? Why not just use the original name? Well, you can't use the original name, right? I can't go in the code and say R3. Where's my rat? Sorry. I can't say R3 dot, age equals 10. Can't do that because I don't know what R3 is. I don't know what the name of this object is. That's what this is for. And I created that. Those really need to go away. If you're following along and you type this dot age equals 10, get rid of that, or else the code is kind of dumb. So default values. If you do not assign a value to a class member, it defaults to 0. So you didn't really have to do age is equal to 0. Nothing wrong with doing it though. That's an explicit initialization. If you wanted to have a non-zero value, you better do it. This one doesn't have a value, so it gets an initial default value of 0. Or if it's a Boolean, it turns false. If it's a floating point, it defaults to 0.0. If it's in class, it gets null. Strings are classes. Strings are reference variables, so they get set to null. So if you don't set it to a default value and you try to print it out, you're just going to see the word null rather than anything else. So variable persistence, that's how long a variable lasts until it disappears. If I do this, this is just going to be a demo. It doesn't really matter. I'm not going to call it, public void test, parentheses and parentheses. And I ought to make it static if I wanted to call it from main. So why not? Public static void test. If I create a variable in it, int x is equal to 7 or 8, whatever, this variable exists only from here to here. However, if I make it a member of the class, static int x, and I take the int out here, there, that works just fine, and the variable does not disappear once it hits the closing brace. Why? Because it's declared outside of the closing braces. Kind of like a global variable in C++, if you've ever taken C++. And in Python, you can create variables and then use them inside of methods, right? Otherwise, this piece of data, this value gets lost unless you use a return statement to get it back out of it to be used by somewhere else. So down here in main, I could do x is equal to 3, 4, I keep mistyping, and then I could call test, and by now, x equals 8. It did not lose its value. If I declared it here, right, if this was a declaration, I deleted that. Well, even if I didn't delete it, the change would not have changed this original value. If I did this, int x, if I created a brand new variable, I'm going to delete that int, by the way, then when I printed out x, x would equal 4 here. Why? Because this is changing the value of a local variable, a variable that is private to this method that only exists from here to here, even though it has the same name, right? Just because you have a dog named Fred, your neighbor has a dog named Fred, they're not the same dog. You trim your dog's toenails, his dog doesn't have trimmed toenails. I have my own private dog inside this method here. It does not change this value here when I change it here. But if I take that out, it's using the class's x variable, and it does change it. So now x really would be 8 if we printed it out. So a local variable is one that's part of a method. And an instance and a class variables are one that are part of the class. Local variables disappear after the closing brace. The so-called garbage collector comes and frees up the memory. In some languages, you have to explicitly free to delete those local variables. Not in this one. Garbage collectors are nice. You don't have to get as complicated as that. So I'm going to add a local variable here just so I can add a comment, right? Int y is equal to 100. Y is a local variable. A local variable is defined inside a method. Its data disappears when the method is exited, unless you return it. If you have a return statement and you return that y, then yeah, something else could use it, unless you return it. Anybody remind me why I had to make that one static, and if I deleted the word static, this line would be an error? I'm going to pick on somebody. Lindy, why did I make this one static? If I delete the word static, it's an error.
Because the next one is static too.
This is a static context. It's a static method, so any other things in the same class also have to be static. You are 100% correct. If I did not make this a static method, then it would be able to call this thing if it was non-static. In other words, if it was an instance variable. Remember, static means class member. Non-static means instance member. So the UML for our rat, or for the mouse, right? We had an age, we had a grams, and we had a % growth rate. So the second block of a UML diagram, the top one being the name of the class, these are the members of the class. Minus signs mean that they're private, plus signs mean that they're public. And they added setters, right? And they also added a grow method. And apparently they didn't put a display method like we did. I thought they did. Maybe it's later in the chapter. So a local variable is declared inside the method. It's called local because it can only be accessed inside the method. If I went here and I wanted to get a hold of that y, too bad. There's no way for me to get a hold of it unless I return it. I'm sorry, people are still typing here, which is fine. It just means I went too fast. All right, we good? All right. So the return statement. Why do you have a return statement? Because if you have a local variable, it's not going to be accessible. So if we wanted to get a hold of that 7, we better return it. Or if we make like a calculate, area method, or square method, we're going to take a number and allow ourselves to square it. I want to write a square method, or cube, because there already is a a square root function or whatever. We're going to write a cube method. It's going to take an argument and it's going to multiply it by itself, 3 times, and then it's going to return it. So public static. If we're going to use a return statement, we cannot declare it as void. So I'm going to call it double. Public static double cube, and we need some input. How about just x, right? Or v for value or something. I'm going to go with x. So let's create a temporary variable to hold our result. Right? Double r for result is equal to x times x times x, semicolon. Now that's great and all, but r is a temporary variable. It's a local variable. Even if main called cube, it would not be able to get that value back. So that's what the return statement is for. Return r. Now we can use it, right? Down here, now I could say double, can I type? Double var equals cube of 10, right? Now it works. So that's what the return statement does, is it throws the value back out of this method so that it can be returned and stored into another variable or used as part of an expression. All right, I'm going to get silly here. Var equals the cube value of the cube value of the cube value of 2. In parentheses, in parentheses, in parentheses, semicolon. So, if you have a math expression, the stuff inside the parentheses happens first. Same with function calls, method calls. So this calls would run up here and return 8, because 8 is 2 times 2 times 2. It would come back out. It would pass in return 8, and then that would be used, I'm going to delete this temporarily, as input for this cube function. And honestly, I don't know what 8 cubed is, so I'm going to make Google tell me. 512. Okay. So when 512 got returned, it would use that as the input for this cube function. And who cares? I'm not going to go cube 512 to find out what it is. So a function's return value can be used as input for another function. And I keep using the word function because I just got done teaching Python. They're called methods here. What is a function? A function is a chunk of code that's not attached to a class. This language doesn't have functions because everything is attached to a class. There's no way to define a function. You can only define methods. All right, getting close to where we need to end. So the return statement here is returning this .age. It has to do that because they declared age as private. Void means it doesn't return anything. If you declare a function as void, you can stick a return statement in it, but then NetBeans is so picky it warns you that you didn't need it. Unnecessary return statement. I like return statements. I don't see anything wrong with that. But just to reduce the number of yellow caution flags, I tend not to do it if it's declared as void. An empty return statement is something that doesn't return any data. There might be times when you need that. Like what if the test method had some kind of conditional statement? Like what if you get to this point right here, and if x equals 7, or which is never going to, right? Then return, right? Now that time that's not an error. That's not a caution. It's not a warning. Because it's a perfectly good statement. It's executed conditionally, and yeah, our logic is that it actually never would be, run. But ignoring that fact. So, since it's declared as void, it doesn't actually have a return value, but it still has to return if that's our logic. And so you'll see methods written like that, to where they rule out some error condition early, better to rule out all the error states early so that the rest of the code is cleaner, so you don't have to keep checking for error conditions, all the way through it. If you can just rule them out at the beginning, find out that there's something wrong before you get there. And we're going to stop here. Pretty close to being done with the chapter, and that's okay. Homework for this. What was our homework last time? Let's go take a peek.
Books and rectangles?
Yeah, the book and rectangle class. Is there anything we want to add to our book and rectangle class? Nah, I don't see anything else that we need to add. Yeah, let's add constructors for them. So, this one's assignment is going to be to add constructors to your book and your rectangle class. So you can just modify them and upload new versions of it, right? You don't need to make a new project. So let's tack this on as a homework description. Modify your book and rectangle class from the last assignment to use parameterized constructors. Add a default constructor as well. Modify your code so that the parameterized constructor is used. Or since we have two of them, make it plural. Constructors are used. All right. That makes sense, gang? We're good to go? Since constructors are talked about in Chapter 7 rather than 6, if this lecture wasn't enough, just go peek into Chapter 7. Or ask me for help. It's always good. All right, I'm going to temporarily tab away from this so that I can make the Dropbox. Then I'll bring it back.